In this video, we are going to talk about Penman method. Our learning outcome is to determine the daily potential evapotranspiration, and this is the formula on how to get or to determine or calculate our potential evapotranspiration, which is represented by PET. And this is equal to A times H sub n plus E sub A times gamma over A plus gamma. Our PET is expressed in mm per day, and A is the slope of the saturation vapor pressure versus temperature curve at the mean air temperature, and this is expressed in mm of mercury per degree Celsius. And this value can be taken from table number 6, and H sub n is the net radiation in mm of evaporable water per day, which can be computed using this formula wherein H sub A is the incident solar radiation outside the atmosphere on a horizontal surface, and this is expressed in mm of evaporable water per day. And this can be taken from table number 7. Our A is the constant depending upon the latitude phi and is given by this formula. A is equal to 0.29 cosine phi. And B is a constant having an average value of 0.52. Small letter n is the actual duration of bright sunshine in hours. The big letter N is the maximum possible hours of bright sunshine. And this is a function of latitude. And this can be taken from table number 8. The R is reflection coefficient or the albedo. And usually, it ranges from these numbers kani. And our sigma is the Stefan Boltzmann constant, which is equal to this number. And T sub A is the mean air temperature in degrees Kelvin, which is equal to 273 plus degrees Celsius. And E sub A is the actual mean vapor pressure in the air in mm of mercury. Now go back to this. E sub A is the parameter including wind velocity and saturation deficit, and this can be computed using this formula, wherein U sub 2 is the mean wind speed at 2 meters above ground in kilometer per day. E sub W is the saturation vapor pressure at mean air temperature in mm of mercury, and this can again be computed using this table number 6. And E sub A is the actual vapor pressure defined earlier, this one. Now we move to our example. Example: calculate the potential evapotranspiration from an area near New Delhi in the month of November by Penman's formula. The following data are available. So this one. Now we start with finding our A. Our A can be taken from the table. This table number 6. Tapos ang requirement para makuha nato ning A is unsa ang iyang temperature. So sa ato ang given we have 19 degrees Celsius. But then, sa ato ang table, dili nimo makita ng 19 degrees Celsius. So, what we are going to do is gamiton nato itong method of interpolation. Example, we have degree Celsius. And we have this A. This is 17.5. So, ang 19 is in between the ring. So, we put 19 and then 20.0, and then on the other side that would be 0.95. Our 19 is X, and then 20 is 1.05. Okay, so we find our X. So we start first from here padulong didto o kanipod nga value padulong didto. So, 20 minus 17.5 equal to 1.05 minus 0.95 over then the next one would be 20 to 19 o 1.05 to x. So this would be 20 minus 19 equal to 1.05 minus x. Now we find what is our x. So we simplify, this would be 2.5 and then this one is 1. Okay, so we cross multiply. So this would be 1.05 minus x is equal to this one. So that would be 1.05 minus 0.95 times 1 divided by 2.5. So our x would be 1.05 minus this term, kaning whole nga term. So our x is equal to 1.01 mm degree Celsius per degree Celsius. So this is our A at 19 degrees Celsius. A is equal to 1.01 mm per degree Celsius. Pero, i-share na ako sa inyo ha class, katong mugamit lang ta og calculator. Mas simpler siya class. Di na mo magamit aning, mag-compute ani. Wait lang. Okay, so, using your calculator, mas madali ni siyang interpolation class. What you do, first is you press mode, and then after that, you will select 3 for stat. And then after, you select 2 for A plus B. So, i-press ninyo ning 2. And after pressing, this will appear, siya nga table. So, what you are going to do is, i-input ninyo tong mga values class. Okay, so sa ato ang case dere, we have 17.5, pagkahuman 20, and then 0.95, and then 1.05. So, after completing, okay, you press equals first, and then after that, you click AC. So, pag na-click na ninyo ng AC, i-click ninyo Shift plus 1. So, Shift, then after, you click 1 for start. And then, you select again 5, reg, for regression, and then, select another 5 for Y hat. Okay, so ang mo-appear karon sa imong screen sa calculator is Y hat. So what you're going to do is insertan nimo og 19 before Y hat. So 19 tapos Y hat, and then after that you press equals, then the result would be 1.01. So next step is we are going to determine our H sub n. And sa H sub n, first, we need to have our H sub A. And our H sub A can be taken from our table number 7. So, this one. So, part of the parameter na gi-require nato para makuha nato ang H sub A is unsa ang latitude. So, ang atong latitude is naa sa 28 degrees 4 minutes north, or that is equivalent to 28.067 degrees north. So, again, mag-interpolate na pud ta. Ang atong gamiton is and then, tungod kay month of November man ang atong pangitaan o potential evaporation, so, mamili lang tag diri lang kanilang values. Okay. Using your calculator, our HA is equal to 9.5059. This is mm water per day. Next, we are going to determine our R. Our R is, this can be taken from this table. Sa atong given is close ground green crop. So, gamito na to kaning first. Sige, 0.25 atong R is equal to 0.25. Next is our A. This is equal to 0.29 cosine phi, and this is equal to 0.29 cosine 28.067. This is equal to 0.2559, and then our B is equal to 0.52, constant yan siya. And then our N is equal to 9 hours sunshine. Our N nga dako, makuha siya diri sa table number 8. Interpolate na podda kana siya og kani. Okay, the answer is 10.715 16 na lang. And then what else? And sigma Stefan Boltzmann is equal to 2.01 times 10 negative 9. And then TA. Our TA is 273 plus degree Celsius. 273 plus 19. This is equal to 292. And then we need this one, the actual vapor pressure. And our actual vapor pressure can be computed using this formula, that relative RH, relative humidity, is equal to the actual vapor pressure over the saturation water vapor. The relative humidity is naatay given diri, which is 75%, so that would be 0.75. And then we are going to find E sub A. Our EW, this can be taken from the table number 6. So, from here, i-interpolate na pod nato para makuha nato ang EW. Our EW is equal to 16.524. Sulat na lang po nato dali. EW is equal to 16.524. So, our E sub A is equal to 16 times 0.75. So, that is equal to 12.392. This is equal to 12.392 mm of mercury, mm of Hg. Now, we solve our H of N. Okay, so our H of N is equal to 9.5059. 1 minus 0.25 times our A, 0.2559, plus B nga 0.52, and then multiplied by kaning N over N is equal to 9. So, 9 divided by 10.716, and this is equal to 0.84. So times 0.84, and then minus Stefan Boltzmann is 2.01 times 10 negative 9, and then multiplied by TA, which is 292 to the power of 4, and then 0.56 minus 0.092, square root of 12.392, and then times 0.1 plus 0.9 times 0.84. This is equal to 4.93855 minus this one minus 2.9537. This is equal to, then this is equal to 1.98 mm per day. Pero if i-try ninyo ni class nga dili mo mag round off, tuloy-tuloy lang ang pag-solve ani sa calculator, then you will come up with a result of 2 mm per day. Okay. So next is we are going to compute this one. We solve for our E sub A. E sub A is equal to 0.35 times 1 plus our U sub 2 is 85 kilometer per day. So it would be 85, and then over 160 times our EW is 16.524. Our E sub A is 12.392. Then this is equal to 2.21 mm per day. So after this, we can now solve our potential evapotranspiration. So we are going to solve for PET. So our A is 1.01 multiplied by our HN, which is 2, and then plus E sub A is 2.21 times our gamma, which is 0.49 all over our A, which is 1.01 plus 0.49. So our potential evapotranspiration is equal to 2.0686 mm per day, or that would be 2.07 mm per day of potential evapotranspiration. So this is now our final answer.